the numerator we write the sum of all probabilities. So to find the odds, we divide. So we find the ratio of probability of that our fruit is in orange in numerator, and in denominator the probability that our fruit is an apple. So to find it, we need to simplify our ratio. So as you see in the slides, we simplified the ratio, and next we in the end we obtain the in numerator exponent to the power of a orange 0 plus a orange 1x divided by e exponent to the power of a apple 0 plus a apple 1x. And we need to, and the last step is to find the log odds. So as we did in the previous problem, we took the logarithm from the left hand side and the right hand side, and we obtained the a orange 0 minus a apple 0 plus a orange 1 x minus a apple 1x. So this is the end. So I grouped the variables with x and the variables without x, just to make it more simple and clear for our eyes. And yeah, okay. And in the C problem, it is stated that we have that in our model we have coefficients beta 0 equal to 2 and beta 1 equal to -1. So, and the question is to find the coefficient, to find the variables for the our friend model. So so basically our logistic regression model and our friend's logistic regression models are equivalent, because in the first case we just used we don't use the softmax coding, and the second case in our friend's model we use the softmax coding. So this is basically the same, but we actually use only the different style of coding. So to find the coefficients, to find the variables for our friend's model, we make equal our friend's model and our model, and the left hand side we write the variables for our friend's model, and the right hand side writes the variables for our model. And and then in the second line we simplified the variables with coefficients, the variables with x, and as you see they are similar. So the variables underlined with black color, and the variables underlined with red color, we can equal them, because the variables with reds with black color, they have they don't have x, and the variables with red color have x. So once we equal them, we obtain the a orange 0 minus a apple 0 equal to 2, and a orange 1 minus a apple 1 equal to minus 1. So as we see, there are many options to there are infinitely many solutions to this equation, because 4 minus 2 gives us can give us 2, 2 minus 0 can give us 2, and for example 2 minus 3 can give us minus 1, 4 minus 5 can give us minus 1, so that's why there are many infinitely solutions. And the D problem, we have opposite situation where we have the variables for our friend's model. So we do the same to find the variables for our model. We equal them, but in this situation we know the value of variables for our friend's model, and we can find the variables for our model, and we obtain that beta 0 is equal to minus 1.8, and beta 1 is equal to minus 2.6. And in the last slide you see the solution to the E. So I said earlier that our models are equivalent, so we'll expect, so that's why we'll expect that they will agree in most of the times. So this previous problems makes us understand that they're equivalent, and gave us the solution to the E.